Morning to all of you. Can you hear me? Anshuman? You can unmute yourself.
Yes.
Okay. So now today we are going to discuss with the image formation. The case of convex lens and concave lens. So for image formation, we require minimum 2 rays. If they are actually meeting, we'll get real image. They appear to diverge from some point, we'll get virtual image. So what are the rays to be considered for the image formation in the case of lenses, convex lens and concave lens? We consider, I'm going to explain 3 different types of rays. Out of that, 2 rays we'll consider for image formation. The first one is convex lens and concave lens. Image formation. Different rays are to be considered. What are the different rays to be taken? First one is ray parallel to principal axis after refraction passes through the focus. This is the case why. Ray parallel to principal axis after refraction passes through the focus. In all the cases, we use this. First preference for this. In all the cases. Similarly for concave. Ray parallel to principal axis, we are showing only one bending and diverge and appear to come from a point here at on the principal axis. So ray parallel to principal axis after refraction passing the focus. Case of convex lens. Ray parallel to principal axis after refraction appear to come from point that is on the principal axis, that is focus. Generally, in all cases, we will make these two. Second one, just reverse of this. Suppose if a ray of light is passed through the focus and reaching. After refraction, it becomes parallel. It becomes parallel. Another ray passing through optic center goes without any deviation. They usually consider one angle. Ray passing through optic center goes without a deviation. Always we consider. Ray parallel to principal axis after refraction path of focus, that also consider. This is same for concave lens also. Ray passing through optic center goes without any. And here the second one. The ray of light, you can see the principal focus on right side of it. Intend to pass through that. Then after refraction it becomes parallel. So these are the rays to be considered for the image formation. So first and third will be considered. First ray and third ray, these two rays are already there. Ray parallel to principal axis after refraction path of focus. Passing through optic center goes without any deviation. Okay, now we are going for image formation in the case of convex lens. Image formation in the case of convex lens. There are 6 cases. Image formation in the case of convex lens. And you have to recognize the position of the image and the nature of image and what is the size, etc. that you have to do. First one, when the object is at infinity. Case 1. Objects at infinity. Object at infinity. We have seen the definition of principal focus. Rays parallel to principal axis, object is at infinity, rays are parallel to principal axis. Object at infinity. After that, converge is the point here. So this point we are getting image at focus. So it's a real image. You can take it on a screen. So this is a real inverted, very diminished image form at focus. It's the real image, invert image, and very diminished image, very small in size. Condition object is at infinity. In between, I'll ask, be careful. Real, inverted, very diminished form at focus. Now here, object is coming closer to the lens. You cannot at infinite distance, at finite distance. So case 2. Case 2, object is beyond 12. Object is beyond 12. Left side में F1 to F1, right side में F2 to F2, but they are all equal in length, so we mark it as F to F easy to recognize. The object is beyond 2F, little more finite distance. AB is your object. So image formation in the case of convex lens is very similar to that of concave mirror. Same kind of image it develops. Convex lens is equivalent to concave mirror for image formation. First ray parallel to principal axis. After refraction passes through the focus. Second ray passing through the optical center goes without any deviation. The first one at this point. We are getting an as a real inverted image between Fn to F on the other side. Real image. But size diminished, not very diminished. First ray parallel to principal axis, after refraction path of the focus. Second ray passing through the optical center goes without a deviation and meeting the first ray at this point. So it has here inverted diminished image. So here we try is the real image. There are rays are actually inverted image. Diminished image between F and 12 on the other side. Okay, between F and 12 on the other side. So this is the second object is finite distance, but it is beyond 12. Image is found between F and 12 on the other side. Real inverted diminished image. Okay, we are bringing little more closer. Object is coming little more closer than the image. Suppose object or passing on, object is coming over closer to the lens when it is at 2F, and the object is at 2F, then we see. Case 3. When the object is at 2F, where is the image and what is the meaning of image? Case 3. When the object is at 2F itself. Object is at 2F. What are the complete this diagram of object? Optical center F12. Object is here, AB is your object. AB is your object. F12. One ray parallel to principal axis. After refraction passes through the focus. Second ray passing through the optic center goes without any deviation. And both are meeting at this point here, and here you are getting and it is at 2F. On the other side, you can see the size of the image is same as size of the object here. Object is at 2F. Real inverted image is formed at 2F and of same size. So the real inverted, same size image, very important, same size image, formed as 2F on the other side. 2F2, we can also say 2F. So when the object is at 2F1, the image will be at 2F. So automatically on the other side, we can complete at least this diagram in the copy. Did you complete the diagram?
Yes, sir.
Okay, you can bring the object a little more closer. Then what will happen? If you are bringing object more closer, the size of the image will increase. It will be magnified image, enlarged image. So that will be case 4. Object is now between F and 2F. Object is between F and 2F. Object is between F and 2F. Case 4. Object is between F and 2F, where will be the image diagram. Pattern of the diagram is same. C, F and 2F. Object is here, it is between F and 2F. First ray parallel visualizes after interaction passing on the focus. Second ray is passing from the center goes without any deviation and first one here. The image is here formed and as B and it is beyond 2F and size is little bigger than the object. So image again here. It is inverted image and it is enlarged image. Bigger in size and it is formed beyond 2F. Formed beyond. Real, inverted, enlarged image beyond 2F. It's very important. Case number 5. Object is a little more closer. Okay, let it be at the focus. The next point, when the object is at the focus. Case number 5. Object at the focus. When object is at the focus, object is at the. It's very important in way objects to see what kind of wavefront we will get when the object is at focus. So you should know the diagram that one we can expect. Optical center and object is at the focus. A is object. First ray parallel reflexes after refraction passes through the focus. Second ray passing through the optic center goes without any deviation. And the first ray and second ray they are parallel. So they are supposed to meet at infinity as you are extending this line. They meet at infinity. So image will be formed at infinity. You can see the distance of the image as it goes like this is the size and increasing. As it increasing and increasing. So image is formed at infinity, it is highly magnified image. So real, inverted, and I say highly magnified image. Highly magnified image. And this is formed at infinity, nothing is at infinity. So what is the condition for getting highly magnified image? The object should be at the focus. The object should be. So this diagram is important and what kind of wavefront we'll get after refraction when the object is at the focus. What is a wavefront, etc. we'll see in the objects. Okay, so diagram when rays are parallel, we get a plane wavefront. How we are getting a parallel aspects. This idea should be there with you. Next one, okay, we are coming a little more closer. And the object is between F and C. You have to complete this diagram. Case number 6. When the object is between F and C, only the case where convex lens form virtual enlarged image. So this case, convex lens forms real image. If it is again coming closer between C and F anywhere, it produces virtual image, cannot be taken on a screen but can be photographed. And this principle will employ in the case of a simple microscope. A simple microscope that we use in physics lab to see the vernier reading. So next diagram, that is case 6 for complete. Case 6 is very important. Object is between F and C. Object is between F and C. A is your object. First ray is diagonal slices. After refraction passes over the focus. Second ray passing through the optic center goes without any deviation. You can see first and second ray, they are not at all meeting. On right side, they are moving. You are standing and observing. You can see that these two rays are here transforming. Extend them backward. Extend this two rays backward. So we will be getting the image at this point. So the image is formed here. Add as here. Virtual image. So virtual image is formed only one piece, one vector is a virtual image when the object is between F and C. So virtual, but the speciality is direct image. All virtual images are correct. Exactly same thing. Your object head is on, here also image head is on. Virtual erect, enlarged, magnified, and formed on the same side. Formed on the same side of the object. It is on left side. So virtual images are on the same side of the object in the case. So remember in the case of the mirror, virtual image is behind the mirror. So here it is on the same side. Virtual images are always on the same side of the object in the case of the lens. So all of you should complete this diagram. One ray pair axis, past the focus, center is diverge and move. Okay, they are diverging and going, so we have to come from the point here, A dash. So we are getting virtual erect, magnified or enlarged image on the same side. This diagram is very important one, and we use this diagram for our simple microscope. Exact same diagram. Optical instrument, first topic is simple microscope. We use this diagram. Are we completed in the copy?
Yes, sir.
Xii Malik. Karan.
Yes, sir.
Completed?
Yes, sir.
Oh, okay. So now we go for, so 6 cases to be completed. And I want to get some answer from you. I'll give the location. Type of image. I just repeat the different cases. Because we use this kind of object position and image, and there will be numerical for this. Or to recognize from lens formula, we have to find out, locate the position of the image and next of it. So first position is when the object is at infinity, the image is at the focus, real, inverted, and very, very diminished. Little more closer beyond 2f. Image is the real inverted. between F and 2F diminished. At 2F, real inverted of same size formed at 2F on the other side. Next one, between F and 2F, real inverted magnified image is formed beyond. When the object is at focus, we get real inverted highly magnified image at infinity. When the object is between F and C, we get virtual direct large image on the same side. This is only one case where we are getting virtual image which are magnified. Okay, so when we discuss magnification, you should require this point for answering that. Anshuman, when will you get highly magnified image?
When the object is at focus.
Okay. Karan, when will you get image size is same as that of the object in the case of convex lens?
When the object is at 2F.
When the object is at. Okay. Now together tell me the condition for getting virtual image in the case of convex lens.
So when the object is between F and C.
Okay, when the object is between F and C. Okay, good. Next one we go for concave lens. Okay, concave lens. Concave lens forms only one type of image, irrespective of the position of the object. You can keep the object anywhere, but only one type of image will be formed. That image is virtual, erect, diminished, formed on the same side of the object. Virtual images are erect, but it is here diminished image formed on the same side. Concave lens. So we'll make two diagrams. One is object at infinity, that is already known to you, and at any finite distance. When object is at infinity, case one, object at infinity. Object at infinity. These are parallel principal axis. After refraction, diagram this appear to come from a point here. So image is formed here at F. So when the object is at infinity, the image is formed at focus. Virtual image, virtual, erect, and very diminished. Very diminished image. Very diminished. Virtual, erect, very diminished, formed at focus. Same size. So this we are saying in the case of principal power definition, there is no change. Arrow mark should be there. Otherwise, half mark will be deducted. Red diagram, arrow mark should be there. Okay. Next is case 2 at any finite distance, or should draw this diagram in the bottom. Case 2, object at any finite distance. At any finite distance means 10 centimeter, 30 centimeter, 40 centimeter, 5 centimeter, anywhere, any finite distance. Case 2, object at any finite distance. 5 centimeter in front of concave lens, 10 centimeter, 20 centimeter, any finite distance. At F2F, anything can be given. So it forms only one type of image. Object is here AB, anywhere. Can be one focal length away, two focal length away, in between, anywhere. No problem. That we generally see that any finite distance. One ray parallel reflection after refraction. Diverges appear to come from this is the point appear to come from the focus. Another ray passing through the optic center goes without any bending. Somebody standing here on the right side and observe. So these two rays appear to come from point here and here you are getting and A dash B dash is the virtual image erects diminished, not very diminished, between C and F. Location is between C and F. When object is at infinity, location of the image is at F. Now it is between C and F. So normally it goes from F to move towards C, depending upon the position. So it's virtual image, erect image, diminished image, Amisha diminished image, and between F and C on same side. So this is the location for image for concave lens for all finite distances. Only one diagram, irrespective of whether it is 1f away, 2f away, in between any finite distance. The image formation is like this. You have to complete this diagram to copy. Virtual image, erect image, diminished image. Formed between F and C. Or to complete this diagram, one. Only one type of image. This is virtual image. Diminished. So tell me the type of lens which produces virtual diminished image.
Convex lens. Concave lens.
It's a concave lens. Tell me the lens which produces virtual enlarged image.
Convex
Convex
lens.
That is convex lens. Convex lens forms virtual magnified always. Virtual magnified lens is convex. Virtual diminished, that is concave. Concave lens always virtual diminished. Convex lens virtual magnified only one condition when the object is lying between F and C. Okay, that's the point. I think all of you completed this diagram. So these are the different diagrams and their image formation and location. Okay, so we have object distance. Object is there, its image is there, and we are saying that focal length, one focal length away, two focal length away. So focal length is there. Object distance we mark it as U, image distance as V, and focal length F. So the relation involving object distance, image distance, and focal length of the lens, we call it as lens formula. It is not lens maker's formula. It is lens formula. Lens formula is object distance of the object from optical center, image distance of the image from the optical center, and focal length. Okay, and focal length. So the relation involving them is 1 by V minus 1 by U is equal to 1 by F. This we call it as lens formula. So this equation was there on left side of the lens maker's formula. This year question was like that. 1 by V minus 1 by equal 1 by F. So this term was there on the left side of lens maker's formula, and we treated by applying special condition as 1 by F. So we have to derive this equation by using any one image formation, either in the case of concave lens or convex lens. Okay, so 1 by V minus 1 by equal 1 by F. This is a lens formula. It is different from lens maker's formula. Lens maker's formula relates focal length, refract index, and radial curvature. Lens formula relates its object distance, image distance, and focal length. Okay, so this equation will continue in the next class. Thank you.